Thank you. Thank you. Welcome, everybody. Thank you for making it out here. My name is Florian Michahelles. I'm coming from Berkeley. I'm leading the artificial and human intelligence research team there for Siemens. And Siemens is an interesting place to work with because Siemens has a very long tradition in industry. So Siemens basically was started when the steam engine was invented. The term didn't exist, but you probably could call it now Industry 1.0, when suddenly things started to move automatically and allowing for mechanical automation. Then with Industry 2.0, when electricity came in, the steam engines could be replaced, and later on electronics came in and allowed for much more fine-grained control of manufacturing. And where we are today is the Industry 4.0, where we have digitalization, where we have data, where we have AI to control machinery, and that of course opens opportunities for manufacturing to offer new services and also offer more fine-grained and better controlled manufacturing. So myself and the group I'm in, we are part of corporate technology, so that's the research arm of Siemens. We are a little bit spread out in the US, more spread out in the world, but in the US our center is in Princeton. Then we have our outlet in Berkeley, where the main reason is to interact with the universities, the startups, and the ecosystem there. And also we have a group in Charlotte that is more focused with the turbine manufacturers. To the topic of my talk. So what we see today is AI is everywhere. It has become a big buzzword. And AI traditionally, if you look also into the movie industries, is creating a lot of fears because the word intelligence and artificial, there's fear of being replaced, robots taking over our work. There's a lot of fear. Some of fear is unjustified, some fear may be justified, but fear is usually irrational, and how can we help to turn AI into something useful? And for that reason, we have coined a term and have developed a technology which is called digital companion, and I want to step into that a little bit more. So the digital companion we see as a partner that actually helps the human user to better and more efficiently achieve the task someone is doing. So the digital companion actually allows to learn from experience and preference and likes of the user in order to adapt to the skill level, to the preferred mode of interaction to the user. Then also consider users' relationships to other people and organizations, so to identify the role and understand what the user actually may need. And then also being capable of contextualizing and customizing the responses so that they make sense for the very specific situation of the user. So the companion is built out of 3 pillars. So one main pillar is the knowledge base. So that's basically the corpus of knowledge that this companion can tap into and then can provide suggestions or recommendations to the user what to do. And I will go into that a little bit more about how we do that on semantic technologies and knowledge graphs. Then the second pillar is the adaptability, so that the digital companion actually can continuously learn about the user, what the user is doing and what the user already knows, and then construct a user model and provide suggestions that make most sense for the user in the very specific situation. And finally, embodiment is the modality, is the mode of interaction. Is it a chatbot? Is it a visual feedback? Is it a voice interface? So what is the preference of the user, but also what's the most applicable in the current situation? And I promised I would go a little bit more into the knowledge representation and the knowledge graph. So as an example, what I'm illustrating here is like the old Google and the new Google. So the old Google, as we used to know it, without a knowledge graph, would actually just, upon a query, you are asking a question about how old is Benjamin Franklin, and what Google, the old Google would do is would just take your terms, would look for keywords that appear in these documents and then rank them about how many other documents are actually providing references to that, and then you get a link to the document which in this case is Wikipedia, and there you hopefully can find the answer to your question by opening and reading through this document. Now, having a knowledge graph, Google actually can do much more. having a knowledge graph, the system can recognize from this query how old is Benjamin Franklin, that Benjamin Franklin apparently is a person. And a person has an age, and can extract this knowledge directly from these articles below, and can also give you references to similar people that are somehow related or relevant to Benjamin Franklin. So this is a much more fine-grained and a much more tailored response than the previous one. So how this basically works is that in addition to the statistics, in addition to the machine learning, we have the knowledge represented in a knowledge graph where we are actually describing the relationships between these entities and then have qualified descriptions about what these relationships actually mean. And then we can traverse this graph when a query comes in and can provide a much more tailored response. And this is then also what we can do when someone is repairing a machine and has question about an error code. So we can do more than just providing the highest occurrence of a search term, but we have the relationships and can actually use that. So it's one approach closer about how our human mind actually works, that we have associations and relationships between entities. Yeah, and what I want to do now is, with all this introduction, I want to show you an example research project that we actually did. So this is a project we did at UC Berkeley about a lathe, a mechanical tool that the user is using. And now the user is manually controlling the tool by the hand wheels. But not only that, the tool has a digital twin where you can define operations, where you can define barriers, and then the tool also can provide feedback to the user. So if the user is drilling too far into the material, the tool can actually block the wheel and can instruct the user. Or by setting these parameters we've just seen, it also can snap in and can provide the user a feeling. Or here about doing this curve, the tool can actually take over and can do the curve in a much more fine-grained way. And another approach that we have here is, you see on the iPad there was a virtual object presented, so that you can go back and forth by trial and error and do your operations, undo the operations, and can then actually work with that. So what we have here, it's a tool that's operated by the human user, but the tool is also giving feedback to the user how to use it. So by doing that, we can capture the knowledge from experienced users and actually transfer that to the unexperienced users that are just learning this. And we're actually interested in transferring this modality of putting learning into the workplace as a new way of having education going on in the workplace in a more integrated way. So by actually being able to model these tools and understanding the level of knowledge what the user has, we can now try out different modalities about how to instruct the user how to use this. Now coming back to the topic of this conference here is, in order to be able to have these tools interacting with the user, we need to have a way how to model and describe the tools. So what we have been working in, and I will provide some more details now, is with the W3C on thing descriptions. And thing descriptions actually is a way about how can we describe the capabilities and the actions and the skills of certain equipment and make this universally available to allow app developers to focus on the logic of the app and not so much on the underlying protocols and the underlying principles. And how this actually works, this is an example of a thing description in the JSON LD-based document format. That in this thing description here, we have different elements that I want to step through now. So first of all, we have some meta description just for the human user to understand what's the name of this thing, and to have some descriptive metaphor about what it actually is. Then we add certain security features, protocols that this thing actually implements. And then more interestingly mentioned here is this different interaction affordances. So what are the actions, what are the properties, and what are the events that this thing actually can produce? And also going further then into how are these actions actually being represented in a JSON vocabulary. And if we do that, also we can build upon existing units, like here in milliseconds, and this is actually described in the IoT schema.org. So to have a unified language and a semantic annotation of that in order to be compatible with other machines that are using the same naming convention. So this allows us to describe the properties on a higher abstraction level. And then also things and relations, links to other things, so to see what is this item, what is this asset compatible with. Protocol bindings finally as well. So now with this thing description format, now we can describe thermometer in this example here, or we can retrofit existing devices, we can describe systems, we can describe robot arms, and by that we actually allow the developer to abstract from the underlying protocols and focus on the application logic. So I want to give you a description now. I want to give you a little demo now how this works. So we have this little robot here, and now by actually stepping into the thing description of the robot, we can now navigate through what are the properties of this robot, what are the actions the robot actually can do, and then we can navigate through and it can actually have a look at these different parameters. And now we can use these descriptions from the thing description actually to provide a little program out of that. So, we don't have to step too deep into the protocols, because we just use the parameters that we can grab from the thing description. We take the actions, what the robot actually can do. So we want to close the gripper, and we want to move the base to a certain location around 75 degrees angle, and then we actually can run the program, and the robot arm moves and closes the gripper, and we can also send a little message to another device. So with this, we actually see how we can abstract from the underlying mechanisms and really focus on the logic of the actual application. Yeah, so if you're interested in, this is what Siemens is actually, a few people of us are actually driving this in the working group in the W3C, but it's actually a broader movement than just Siemens. But of course, we have a strong interest in actually driving this. So currently, this working group has about 200 members. There's also exploration and liaisons with industry working groups, like E-Class is mentioned here, OPC UA Foundation is mentioned here, IETF is mentioned here. So to integrate these different vocabularies and different standards into this thing description in order to make the life easier for developers building applications for the Internet of Things. And yeah, I'm not sure that probably there is Ellen Bird here from W3C, who may also have a booth and the World Cafe. And if you have more questions, of course, you can also reach out to me. And this working group is still looking for contributors, and is looking for your input, and is really trying to make this a bigger movement and a more useful format that hopefully helps all of us to make application development faster and easier. So I want to wrap up my talk with this brief summary here. So I started with artificial intelligence, so I think we should not be afraid of it, but we have to find a way about how to wrap AI into a useful tool for us. So this actually requires that we have oversight, that we are in charge, and just are aware that artificial intelligence, there's nothing really artificial and intelligent. It's more about that we provide data, and we have a different way of programming our systems. And whatever data we provide and train our systems, this also defines the output. So there is no magic actually, but still it's a very useful tool. What we also see, there's a strong convergence between AI and IoT, because we do not just want to live in the digital world, but we want to take action in our physical world. So that's why it's important to develop workforce, to develop experts that actually are confident in both worlds and have the right skills to bridge between IoT and AI. And finally, I presented the thing description as an integration layer to accelerate the development of applications and make the life easier for developers. That's the end of my talk. Thank you very much, and I'm looking forward to your questions.
That's wonderful. Thank you, Florian.